Welcome to another episode on my riding robot Discovery based on the fischertechnik TXT controller. And the controller is running embedded Linux, program in Python, and so far results have been quite mixed. I have changed the program such that two motor actions are in a sync data block, and that is necessary to get some actions nicely synchronized, nicely executed, and all in the hope that it drives a straight line. Also, a program is meant or supposed to give some audio signals and give a light signal. And both of those are not really executed always. Sometimes the audio doesn't work, sometimes the light doesn't work and turns in the end of the track and not so much. So what I first want to do is, with the battery packs right here, measuring if they are exactly at the same distance from the middle line. So this is 7 centimeters, and then this is 7 centimeters. I'm not going to use this ruler for sonar because it's conical like this, so it will sense the objects anyway. And I hope to get some nice results, so let's run it. And I start the program via SSH on the controller. In itself a nice thing, except for it touches both contacts and it runs therefore in a perfect straight line, which doesn't happen too often. So let me set everything back, hoping that the controller stays on. Let me then remove one of the battery packs, or more appropriately for testing, never test once, and let's see what happens. I think that's better. So once again, 7 centimeters, 7 centimeters. Let's run again. And this is not a straight line. So this already shows how things go. A little bit turned to this right, to this way, because it touches the right, the left side battery pack. Then it turns this way and not straight line. So that already confirms how things can go wrong despite the programming, the change in the programming. So what next? Well, next thing is of course another test. This is nicely in line. Then 7 centimeters and 7 centimeters. Let's see what happens this time. So much for a straight line. And something that is remarkable is that the diversion is 90% of the time into this direction. So it doesn't go this way, it goes that way. And the question is, why is that exactly? Because of the programming? Well, I've seen the program so many times, I doubt it. Must be something in the motors or so. But then again, let's do it again. See whatever happens. The battery packs were hardly touched, so this is not exactly what I had in mind. This is clearly a horn for sonar distance. And by the looks of it, it doesn't go anywhere soon. So let me just remove the battery pack, see what happens. And right now this is happening. Just a few centimeters away, and with a few I mean some 13 centimeters away, or measuring from here 12 centimeters away or so. It drives on, no extra sound, and it stops. So that's curious also. So let's yeah, what else can I test? Take this one away. Who knows? Alright, 7 centimeters. And when I am on the other place for the oscilloscope measurements, I can't do this, I can't write this far. And this is just another test with another result. So whatever this is caused by, I need to look at the algorithm again. That's the only conclusion I can draw right now. Well, I can do one more test with the battery packs directly adjacent. So there's one here and there's one here. Let's see what happens now. And one thing is, of course, the place where the diversion starts, which is right here, not here. It isn't a curve, it starts right here and then in a straight line. And now of course it doesn't do a thing, so let me do one more thing. And that wasn't even necessary. It just stops. Don't ask me why, it just stops. So one more try. And I actually do not even care where the battery packs are. Let's just run it. Diversion starts straight away. And that's it. So actually the course as it happens is that it starts, it diverts and it turns a bit around and it ends parallel to the central line, to this central line, exactly parallel. Which is a weird idea anyway. So what happens if I just let it run? No battery packs, and just see what happens. As long as the battery pack which is using it doesn't fail. And there it goes, on and on and on. I haven't tested it for a long time, but that's a nice idea. So let me just turn it around. And there it comes. I turned it around manually. And by the way, it was meeting some kind of household appliance and it didn't even stop. neither does it here. And now it is meeting with some object. It stops, but no sign at all. Doesn't stop, nothing. Well, it clearly had to be sensed by the sonar. So this is very weird. And we're at the oscilloscope testing place again. And now the very big question is, of course, what will happen? Well, I have left out the battery packs because now testing shows that at a longer distance it shows a different behavior. So now I do hope that is going to work out right here, although I'm not quite sure. Anyway, let's try. Now this happened just before putting on the controller in the first place as well. Now works. And yes, this is the community firmware, which also means that I can just log in like this, and let's hope that works also here. Something weakness in the wires, otherwise it wouldn't work at all. There we are. So yes, right, let's see what happens, and more specifically here, because now for some reason this may get interesting. Because of the longer distance, I am now very curious if the probes will stay in place, but we'll see anyway. Oh, alright, I didn't expect that to happen. Controller just powered off, just like that. And if I look at this probe, it just softly, very softly leans against the power wire. So if I turn this a little bit like that, would that matter? Otherwise, I saw a nice signal here for a moment, so let's just do this. Oh, and I have to power on, of course. And then let's hope that the yellow probe doesn't touch the battery wire again. Because that really shortens the testing time, which I don't like. And it's almost there. Now it's there. go. Now yeah, camera connected, great. Oh, that's interesting. Although not quite. Alright, let's analyze. First it takes a diversion to one side, then to the other. And it clearly doesn't touch the battery wire. In no way. Nor does this, and yet it goes power off. Will it power on in this place? Oh, something else. This probe has come loose. Alright. Let's give in a little bit to the wires. And let's see what happens from here. So now I have to do this to the camera. And here you see the pole where the oscilloscope camera is mounted. And this is the base of for the probe wires. So now it's running again. I'm in. What happens, if anything? A very nice pulse modulation signal. Let me yeah, that is sonar, I think. But another thing is that this material is exactly the same thickness as the height of the switches, the touch sensors. So it can't go on running for too long. Now gently move it here. It's still running. One more attempt. Keeping my hand right here, although that shouldn't even be necessary. Right. What does it bump into? Alright, that light was because I touched this sensor. But why didn't it write on? That's a big question. So, yet another test. But the diversion was massive. And it absolutely, let me see, yes, of course. Alright, let me, yes, what happens is that, and that is construction stuff, this and this one touch a switch, and the switch is mounted, connected at the underside to this frame. So and that disables it from mounting the plate. So if I construct it in another way, it might write on. It just might do that. And with a little bit of reconstruction with this plate completely moved from bottom to top, and it still clicks nicely, so that's good. One cause of obstruction should be gone, so let's test. I don't want to see that. That's what I want to see. Yeah, and with such strong diversion, it's not even necessary to reconstruct. But on the other hand, this shows that well, to me it's totally unpredictable. And this one is again off. Excuse me. This one for pulse width modulation for one of the motors is totally off, and in the meantime controller goes power off. So that really doesn't help. I'm glad that the battery holds on, or holds for now. And let's take a last look at the code as well. This stuff really is not helping. Alright, we're there again. So first log in here, then in here for a look at the code. Yes, going down. This is the big chunk of code, and this is the first block. Speed of 256, which is half the speed, I think. Then addition for 2500 whatever, and then do anything until contact. So this part is already gone wrong. Here it doesn't sync at all. Well, it doesn't think either, because it's not artificial intelligence, but it doesn't synchronize, and beats me why. Anyway, time for a last test for this episode, and let's hope that this construction comes handy now. Yeah, more or less. Yeah, and that's because, and that last one was because I held my hand in front of the sonar. But alright, conclusion. No conclusion yet. Inconclusive. Well, one conclusion is it still doesn't synchronize at all. Not at all. That's not entirely true, because on the floor test it did synchronize a bit, but here it runs in a curve and goes straight again, which I saw on the floor test as well. So whatever is happening, but I better change this construction like into this one as well. I think that's an improvement. Then it won't bump into something like this. And for the rest, more testing is necessary, I think. For now, thank you for watching. If you like this video, please subscribe to my channel if you haven't done so already, and like the video. If you can follow me on Twitter, retweet and like, and you can follow me on Instagram as well, and like. Please donate to keep the videos coming your way. More information on my website, and this is going to be continued, obviously. So for now, bye bye.